In a closed system without any external forces acting, momentum always stays exactly the same, and a great example of this is the model of Newton's cradle. Now, this model demonstrates the principle of conservation of momentum as well as the conservation of energy. And this is based on Newton's third law, which says to every action there is equal and opposite reaction. Now, what is law of conservation of momentum? It states that the total momentum of an isolated system of interacting particles is conserved. So let us see this through this model of Newton's cradle. Now, if I take one marble ball out of this Newton's cradle and let it go, so let us see what happens. When it collides, exactly one marble will come out and the other side with exactly the same speed. So this happens because of law of conservation of momentum. Now, if I take two marbles, then what will happen? Now let us test this with two opposite spheres acting in opposite direction. So what we can see is that when they are lifted and released, the two spheres on the opposite end will swing out, illustrating the transfer of energy and momentum in pairs. So through this experiment, we can conclude two principles that were demonstrated. The first one is conservation of momentum, which states that the total momentum before and after the collision remains the same. And the second one is conservation of energy. In an ideal Newton's cradle, the total kinetic energy of the system is conserved. However, in reality, some energy is lost to sound, heat and deformations. And the equations involved are as follows.